All right, so this one here, this one's a bit of a tough cookie. It was one of the harder ones from this year. I can't draw up there, so I'll give you a second to read over it. So we've got this wonderful graph here, which I wish I could draw all over, but I can't. It's not going to be a huge issue. So I'll give you a second to pause and read. All right, so we're going to start with the first one. What values of x is f of x increasing? Now, it is increasing when the first derivative is greater than 0. We know from this graph here that this graph is, I wish I could point up to it, but it's, oh God, what have I done there? But it's in that row there, that this is the graph of the first derivative. So which means it's when that first derivative is greater than 0. So it's between 0 and 2. Now it's not equal to 2 because, and that comes kind of into the next part right there, the maximum value. Because when the first derivative is equal to 0, it's a stationary point. So it's going to end up being a stationary point at that value of the curve. So that's going to end up being really important. And it's the only stationary point we've got. It must be a maximum because, once again, it's the only time the first derivative is equal to 0. So it's got to end up being, it's got to be stationary there. And that must mean it must be the maximum. Now, this is where things get a little bit wild. We know the area, A1, is equal to 4. So we know the area under the curve between 0 and 2 is 4. So if we integrate between 2 and 0, and we integrate the derivative, we're going to get 4. Well, now, what does the integral of the derivative become? It becomes the value of the curve itself, which means it becomes f of x between 2 and 0, and we know that's equal to 4. If we sub in like normal, f of 2 minus f of 0 is equal to 4. Let's go back. If we look at that first line right there, let f of y equals f of x be the function defined for that interval with f of 0 is equal to 0. So that must mean this right there is equal to 0. So f of 2 minus 0 is equal to 4. Therefore, f of 2 is equal to 4, which means the max value is 4. And 2, 4 is also the value of the stationary point. And that's going to be useful for our part 4 when we graph it in a little bit. Find the value of f of 6. Now, where this ends up going is, if we notice by looking at this graph, what do we notice between 4 and 6? Well, what we notice between 4 and 6 is that the graph is straight. And if the graph is straight, that is going to be extremely, extremely, extremely important. Because if the graph is straight for the derivative, we know that it is a straight line for our regular curve at that point. Because a linear graph of y equals 2x differentiates to the gradient y equals 2 at that point. So from here, if we take a look, what we do know is we know that f of 4, or f dash of 4, sorry, is the same as f dash of 6 at that point. And what do we know that is equal to? It's equal to -3, which is the value of my gradient at that point. And if we want to look at the value of f of 6, well, from 4 to 6 is 2. So which means we're going to double that value. So that means at f of 6, we're going to end up with -6 because of what this graph means. What the graph of the derivative means in terms of a straight line refers to a constant gradient. That gradient is -3. We know it from the graph. We know that f dash 4 is equal to -3. We know that's the value of the gradient at that point. And we know it's the same at 6. And so because from 4 to 6 is constant, it starts at 4. -6 is where it's going to start. It's going to go up -3, up -3 to a total of -6. And now we've got to actually graph this thing. So we know that at 6, we know it's -6. We just determined that then. And we know it's a straight line from that point from 4. We know it's pretty much going to be a straight line there. We also know that 2, 4 is the turning point, and we know f of 0 is 0. And we know that's going to be concave down, and so my curve's going to look like this absolute monstrosity. Tough one, a lot of theory, but hopefully this helped.